Assign an E or Z configuration to these dicarboxylic acids, each of which is an intermediate in the tricarboxylic acid cycle. So in order for us to assign the E-Z configuration, I'm going to give you the Myers way. And basically what we do is we find the double bond, C double bond C, which is right here, and let's highlight it. And in our mind, we cut it in half. So we will look at each half separately. Let's look at the top half separately. So we forget the bottom half and we look at this carbon separately. What two atoms is this carbon attached to? This carbon is attached to hydrogen and carbon. Who is bigger on the periodic table, hydrogen or carbon? Who has a bigger atomic number, atomic mass? Carbon has a bigger atomic mass, so this wins right away. This is the winner. Now that I'm done with the top carbon, I'm going to go to the bottom half, the bottom carbon. Again, I ask myself, what two atoms is this carbon attached to? Hydrogen, carbon. Right away we see a difference. Carbon is bigger than hydrogen, so this wins. And what I'm going to do next is I'm going to see are these two circles on the same side of the double bond or on the opposite side of double bond. So if I go ahead and if I put the line through the double bond like this, are they on the same side or are they on the opposite side? And you can see they're on the opposite side. Opposite side is E. The way I remember it is I memorize Z, I remember same, same. So for same side, it must be Z, Z same. So opposite side must be E. And let's do the same for this molecule. So we have here C double bond C, that's what we look for first, and I will highlight it. And again, I basically break the double bond in half in my mind, and I'm going to look at each half separately. This carbon is attached to a carbon and a hydrogen. Who wins? A carbon, like we said before, so this is going to win. This carbon is attached to a carbon and a carbon. There is no difference yet, so we must keep on going until we see a difference. The carbon here is attached to two oxygens. The carbon here is attached to one carbon and some hydrogens. So who's going to win? Oxygens are bigger, so this carbon is winning. Again, our carbon on the right is attached to carbon here and a carbon here, no difference. But this carbon is attached to two oxygens and this carbon is attached to two hydrogens and a carbon. Oxygens are bigger on the periodic table, so this side is winning. Now that we have done this, we can erase this line to not confuse us, and we have to ask, are the two circles, are they on the same side of the double bond or are they on the opposite side of the double bond? And you can see that they're on the same side of the double bond. So this must be Z. Remember, Z is same. So my molecule on the left is E and my molecule on the right is Z. This is Maya Lochi from Transformation Tutoring. Let me know if you have any questions in the comments below.